So let us now see that with the help of the point that I was mentioning, that with the help of such kind of IP arrangement among different subnets, how do we create the routing table? So the objective of this routing table is that whenever a particular router, say here in this diagram we have shown different routers, when a particular router receives a packet, how it will decide that where to forward it. Well, so for example, say this intermediate router from the subnet 203.110.8.0/21, it receives a packet, and then it need to decide that where it should forward that particular packet, whether it will forward it to VGSUM, whether it will forward it to E, or whether it will forward to the router which is connected with CIC or something else. Okay. So that the router has to decide. So how it will decide? So here is the thing. So here I have shown you a network configuration. Say with R2, I have 3 different subnets which are connected: 10.0.2.0/24, 10.0.3.0/24, 10.0.4.0/24. Okay. Now R2 is connected with R1, R1 is connected with R3. And remember that in case of routers, the routers has multiple interfaces that I was just mentioning before taking the break. That a router has multiple interfaces, and each interfaces will get an IP address from the corresponding subnet. So for example, this particular interface of R2, it is connected with the subnet 10.0.2.0/24. So it will receive an IP from this subnet, and the IP is say 10.0.2.1/24. That IP is given to this particular interface of the subnet. Similarly, to the interface, router interface, which is connected to the subnet 10.0.3.0/24, the IP given to the interface as 10.0.3.1/24. One IP from this pool of IP addresses provided to the subnet. Okay. So similarly, R1 has 2 different interfaces, ETH0 and ETH1. So we are just naming those interfaces. And remember that whenever we are naming these interfaces as ETH0 and ETH1, they are actually associated with their MAC address. Okay, so typically I think you have already learned that we use 2 different addresses in forwarding a packet. The IP address or the logical address, and the physical address or the MAC address. So IP address is something like your postal address. Well, say for example, for me it is Shondip Chakraborty, CSC 311, Department of Computer Science and Engineering, IIT Kharagpur, Kharagpur 721302. And MAC address is like my Aadhaar card or some unique number globally through which someone can validate that this is me. Well, this is not a different Shondip Chakraborty. Maybe my Aadhaar card number, maybe my passport number, something like that. So that is the MAC address. So this logical IP address is typically used to find out the location of a network or location of a machine, and the MAC address is used for uniquely identify a machine in that location. Okay, so always remember that. So the IP address is actually signifies the location of a machine in the global internet, and the MAC address signifies the individual or uniquely identifies the individual machine or individual network interface card in that location. Okay, so that way the IP addresses are actually used to find out the final subnet where the machine resides, and once the packet is delivered at the final subnet, then it uses the MAC address to physically deliver the packet to that host. So the detailed procedure we'll discuss later on, but that is the kind of the broad idea or the bird's eye view about how the packets are being delivered. Okay, so that's why every interface will have an IP address as well as a MAC address. Typically, in case of router or an interface, whenever we write it down as something like ETH0 or ETH1, these names are actually associated with its MAC address. a short form of the MAC address. So the MAC address is a 48-bit long address. We just resemble it with such names, ETH0, ETH1, WLAN0, WLAN1, something like that. Now let us see that how the routing table for R1 will look like. So the routing table for R1 will look like something like that. I would put 4 different entries. These are the primary entries. Typically in a router, there are multiple other entries which typically happen. I will show it to you. So I will have the network IP, the net mask, the gateway or the default gateway. That means through the IP address that you can reach here, and the interface through which you can reach the gateway. Okay. So here is an example. Say for example, the network address 10.0.2.0. So this particular network having IP address of 10.0.2.0 and subnet as /24. That means 255.255.255.0. Okay. So if you want to forward this packet from R1, what you have to do? You have to forward the packet to this IP address 172.16.2.22. Okay. Now, how will you reach to this and this interface 172.16.2.2? That is an interface of R2, which is connected with R1. Well, now the final entry, it actually says that how will you reach to this interface or reach to this gateway 172.16.2.2 through ETH1. So that is my interface information. And why do we put the gateway as well as the interface information? Remember that here we are talking about from the layer 3 or the IP layer, and I can have multiple other layer 2 devices in between. So it might happen that I have one layer 2 switch in between and 2 different routers, R2 and R1, both are connected to ETH1 of R1 through that L2 switch or layer 2 switch. Okay, it is not necessary that this ETH1, that means the interface 172.16.2.1 is directly connected to 172.16.2.2. There might be a L2 switch in between, and that L2 switch can further divide the network at the MAC layer. And it might happen that I have another router R4, its interface is also connected to ETH1 through this that particular switch. Okay. So that's why I need both the gateway information as well as the interface information in my routing table. Okay. So that way I put the other entries in the router, say that for the subnet 10.0.3.0 and the subnet mask 255.255.255.0. My default gateway is the same 172.16.2.2 and interface ETH1. Then the entry for the subnet 10.0.4.0 in the same way. Then I have a special entry. Okay, so what is the special entry? 0.0.0.0, 0.0.0.0. So both network IP and the subnet IP are the same. What does it mean? It basically means that, well, this is the kind of default entry. That means if I do not get any match in the previous entries, then I will forward the packet to interface 172.16.1.1 with ETH0. So that is a default entry which is made to every router. Typically, this entry is made manually. Okay, that if you do not have any kind of match with the previous entries where you are going to forward the packet. So this entry is called the default entry. Then say the other entries, say for the subnet 172.16.1.0. Okay, so for particularly the interfaces which are connected to R3. Well, so for that my gateway is 172.16.1.1 and the interface is ETH0. Okay. Now, so that way I basically populate the routing table. Now, how the routing is being done? So whenever a R1 receives a packet, okay, so it looks into the destination IP of it. Well, say the destination IP is 10.0.2.5. Well, so what it will do, it will take the destination IP, and remember in a packet we do not put the subnet mask. The subnet mask information is only used at the routing table. Well, so the packet will only contain the source IP and the destination IP. Now, once you get the destination IP, say the destination IP is 10.0.2.4, you take that destination IP, make a logical end of this net mask in the order of entries in the routing table. That means I will first do a ANDing of the first net mask. If there is a match, fine. If there is no match, I will go to the second entry and again make a AND with the net mask there. Again, if there is not an entry, not a match, I will go to the third entry and that way. So I will process the entries in the routing table one by one in the order they are there. Okay. Now I take a IP address from the destination IP field of a packet. Say the IP address is 10.0.2.4. I make a logical AND with the net mask. Say if I make a logical AND of 10.0.2.4 with 255.255.255.0, I will get a 10.0.2.0. So there is a match with the network IP. What does it say? It basically says that the destination IP of this packet belongs to the network 10.0.2.0. Then you look into the gateway information, which actually says that what is going to be your next hop, where you are going to forward the packet further, and the interface through which you are going to forward the packet. So it will see that, well, the interface is ETH1, so it will forward the packet to the outgoing interface of ETH1. Well, so this is the typical routing procedure that is being followed at every router. Is it clear or any doubt? Or do you want me to repeat it? Let me repeat it once. So once you are getting a packet, a data packet, you extract the IP header. From the IP header, you check what is the destination IP, take the destination IP, make a logical AND with the net mask in the routing table in the order of the entries. That means you will check the first order first, then you will check the second entry, then you will check the third entry and so on. So whenever there you are getting a match, that means you are making a logical AND of the destination IP with the net mask. So once you are making a logical AND, you will get an IP address which is the network IP. If it is matched with the corresponding network IP information in the table, that means I get a match in that particular row. And then you pick up the gateway. That is going to be your next hop, next layer 3 hop of the packet. And how will you reach to that layer 3 hop? Through the interface information which is there. Okay. So you forward the packet to the outgoing interface of that particular network interface card. Here it is, if it is a match with 10.0.2.0, you forward it to the network interface card, the outgoing buffer of the network interface card of ETH1. Okay. Okay. So I hope that the process is clear to you. Well, now we can actually compact the routing table with the help of this CIDR. Okay, so you see that in case of this routing path construction, what we are actually doing, we are trying to make a match with each entry of the routing table. Well, so that way, if I have a large number of entries in the routing table, the procedure will become complicated, much more complicated. Well, so the question comes that how do you compact the routing table? And there also we can use this compaction of routing table with the help of the CIDR information. Okay, how can I do it? Here you see that for these 3 entries, your net mask is same, your gateway is same, and your interface is same. So you can combine these 3 entries together and you can put a single entry that 10.0.0.0. Net mask you change it as 255.255.0.0. The gateway and the interface remains the same as it is. So basically, I am combining these 3 entries, taking the net mask information. Okay, basically making this third octet as common. Okay, so making this 255.0 as 0.0 in the net mask information, and combine these 3 entries together to make a single entry. Okay, and that becomes the compact routing table for RO. Okay, so that way, by using CIDR, you can do such kind of compaction in the routing table. Now, there is another problem of doing such kind of compaction. Yeah.
Sir, can you go back to last?
Yeah,
Sir, how does the network column is filled in last slide, previous slide? Go to
how does the
the
network column is filled?
Yes.
Right. So if you look into this network address 10.0.2.0, 10.0.3.0, 10.0.4.0, right? And for all these three network, my net mask is 255.255.255.0. Now, how I can combine these three subnets together, right? So all these three subnets are part of the network IP 10.0.0.0 with a net mask as 255.255.0.0, right? Just think of it in a reverse direction. So if you have a network IP of 10.0.0.0, well, and a net mask of 255.255.0.0, from there you can create these three subnets, right? So if you just take that instead of 16 bits, if you take 24 bits as the network part of your subnet IP, then from 10.0.0.0 slash 16, you can create 10.0.2.0 slash 24, 10.0.3.0 slash 24, 10.0.4.0 slash 24, right? And for all these three subnets, I see that the gateway is same and the interface is same. That means all the three subnets are connected to the same interface of my outgoing router. And I do not have any kind of similar entries in my routing table.
Sir, sir, in network column, the value for the network should be the child of next router. Like if we consider this as a tree hierarchy. So it should be 2.1 to 3.1 and 4.1. R1 is connected to R. 2.1 slash 24 to 3.1 slash 24.
No, that are, see, 2.1, 3.1, 4.1, these are not the IPs of the subnet. These are the IPs which are assigned to these interfaces of R2 from the subnet 10.0.2.0 slash 24. Okay, so from this block of IP address, see, in a router, in your typical computer, in your laptop, you have a network, you have a single network interface card. Okay, through that network interface card, you are connecting a RJ45 cable to connect your machine to the LAN, right? But in case of router is connecting multiple different subnets together, multiple different network together. So a router typically have more than one network interface cards. Means even if you connect 4 different network interface cards to your laptop or to your desktop, you can make it work like a router. Okay, although it is not going to be an optimized router, but you can make it work logically. You can make it work like a router. Now the question comes that what IP address should I take to the interface card of the router? So that comes from the subnet IP of the subnet where that interface is connected. Here, the interface which is connected to the subnet 10.0.2.0 slash 24. So it will get an IP address from that subnet. Okay, so the IP address is 10.0.2.1, which is taken from the subnet 10.0.2.0. And that IP address is assigned to this interface. Okay. Similarly, the laptops or the desktops which will be connected to this interface and the part of this subnet 10.0.2.0, it will get the other IP address. Like one can get 10.0.2.2, one can get 10.0.2.3, another one can get 10.0.2.4, something like that. But while we are putting the entries in the routing table, well, we will not put entries for every individual host. We'll put the entries for the combined subnet. So that's why we will not put an entry for 10.0.2.1 because it is an IP from that subnet. Rather, we will put the address of this entire subnet, which is 10.0.2.0.
Okay, sir.
Clear,
Thank
but still have the doubt.
you. No, sir. Clear.
Okay.
Sir, I have one doubt. Sir, what
Yes,
does
sure.
the 0.0.0.0 enter signify? Like if we put it at the fourth position, then won't like if we give the address as 172.16.2.2, then in that case, wouldn't it like end up at the fourth entry itself if we're checking from the top? Because
Excellent
that
point.
would always
Actually, yeah.
satisfy.
This is an excellent point, and that is the reason I actually wanted to put it in between, just to see whether any one of you can catch this. Okay, so I thought of to mention it at the end. Yes, you are right. So if you are putting 0.0.0.0 here, that means it is ending here. Well, so even if you are putting up 172.16.1.0, it will have a match with 0.0.0.0. Well, and it will end here. Well, so that is why the recommendation is that you put this default entries at the end. Well, so again, that is a kind of historical recommendation. Well, right now we do not need that recommendation because of certain problems. I am coming to that problem. Okay, just hold for a minute. Let me see if there are other questions. Then I will go to that part.
Sure, sir.
Okay, so this entry-wise sequential matching that you will just end when there is a single match. That part was good until we move to a different kind of architecture. I'll mention that part. But any other question? Otherwise, I'll move to that part. Okay, let me explain that. So this is the basic problem, which we call as the multi-home. What is multi-homing? The multi-homing basically says that, well, there may be two different routers through which you can reach a particular subnet. Okay, so a subnet might have two different gateways rather than having a single gateway. That is always possible, and nowadays that is being done for different purposes, for load balancing, for security. Well, so there are different reasons because of which people do that. Now, when there are multi-homing, the problem is that how you are going to make this kind of entries. Well, so what you have to do for this second router, for this blue router, you have to make some kind of additional entries. Well, so what happens that the supernetting is not perfect in this case. Well, so you cannot say, so I think someone of you just mentioned that I can visualize the entire structure as a tree, but whenever we move to this concept of multi-homing, it is not more a tree, not a tree anymore, right? So here you can see that I can have a path through here. I can also have a path through the blue router. Well, and at that time, how I can do the compaction or what will be the effect of supernetting? So with supernetting, I can have a single entry like 10.0.0.0, and the gateway becomes 172.16.2.2. But I see that I have another entry through which I can reach to 10.0.4.0, okay, via this blue router. So for this blue router, I will have another additional entry 10.0.4.0 and interface is ETH2. Now here you see there is a problem. Well, so if I say that where to forward 10.0.4.8, you can get a match with the first entry. You can also get a match with the second entry. If you say that I will always make a match with the first entry, it might happen that it is the longest path, or it is not the shortest path, or that path is a loaded path, or many such things can happen. So that is the reason the network designers have taken a kind of greedy choice. Again, this is a greedy choice. Well, you can find out a lot of exception out of it. You can call it as a kind of jugaad. Again, means as I have mentioned at the beginning of today's class, that in network we do a lot of jugaad. So this is again another example of jugaad. We use an idea called longest prefix match. What is this longest prefix match? The longest prefix match basically says that in the network IP where you can get a maximum match, you take that and you forward it, because that part is a more precise part. Okay, so so 10.0.0, I know that, well, my address belongs to that particular subnet, but 10.0.4.0 is a more precise entry. Okay, so it has a shorter entry. So typically the idea is something like that. So lots of packet will go to 10.0.0.0, but only a few packets which are a part of 10.0.4.0 that will go to 10.0.4.0. Okay, so that's why you take the entry which contains the longest prefix match. And because of that reason, by the time people started introducing this concept of longest prefix match to solve the problem of multi-homing, that earlier idea that you stop whenever you are getting a match, that idea got deprecated. Well, so now the new idea is you keep on matching in the order, but you match with all the entries. And if you get more than one match, then you pick up the one having the longest prefix or the longest match. Now, in this case, you can see there is also a match with 0.0.0.0, but it is always like a precise IP, which is having a match will be longer than 0.0.0.0, right? So that's why even if we put 0.0.0.0 at the middle, that is not going to create any problem, because we are always relying on the longest match, where I have the match up to the longest number of bits in the network IP field. Okay, so is your doubt clear? I put up a new concept as well as tried to clear your doubt.
Yes, sir. Thank you, sir.
Okay, good. Now to do this longest prefix match, so here you see the challenge here is that I need to do a match with all the entries, right? Now, whenever I have to do a match with all the entries, obviously it is a computationally expensive process. And remember that in a router, this routing table lookup need to be done for all the packets that you receive in the router. Well, and that way, the challenge here is that it is computationally complex. So it will take a lot of time computationally. So how can we optimize it? Now, to optimize it, we take one specific type of tree architecture, which is called a Patricia tree. A Patricia tree is a compact representation of trie that is used for matching prefix. Okay, so all the entries in a routing table, they are actually represented in the form of a Patricia tree. So the idea is something like here. So you get a match at 0, then you check whether you have a match at 0, 0. Okay, if you have a match at 0, 0, then you check whether you have a match at 0, 0, 0. Well, or you have a match at 1, then you check whether you have a match at 1, 0. Then you check whether you can go to further down to the tree having a match with 1, 0, 0 or 1, 0, 1. Okay, so that way you can find out that in which level of the tree you have a maximum match, and the searching is in the order of log n. Well, so that way you can reduce the search complexity in a routing table using this Patricia tree. Okay, the data structure through which we represent the IP addresses for doing a first match. Okay, so that is all about the IP addressing and how do we use IP addressing for routing. Any further doubt up to this point? Okay, so I think this all this concept is clear to you, and so today I am going to stop here, not starting a new topic. Just to give you an idea that till now we have seen that, well, if I have this routing table, I can find out, or I can have a match in the routing table to find out that what is going to be my next hop. Okay, but the question comes that how do we construct this routing table? Because how will you find out that, well, subnet 10.0.3.0 is actually connected to the interface 172.16.2.2? For that, you need the entire network graph, right? So in the next class, in the next Monday class, we are going to talk about that how we are going to construct this routing table from a typical network having CIDR. Okay, so we'll see that what are the different control protocols we are going to use, how we are going to find out the different parts that I have in my routing table and so on. Now that is the thing we are going to cover in the next class. Now just before closing today's session, let me just show something to you. Okay, so I hope my desktop is visible. So just let me show you that in a Linux-based machine, how can you check the routing table entries? You can actually check the routing table entries in your machine. And remember that nowadays our laptops are typically having more than one interface. So we can have a wired interface, we can have a wireless interface. Well, so typically whenever you are connected through a RJ45 cable, you can also have a Wi-Fi network through which you can connect to the internet. So that way, every host having this layer 3 protocol running can behave like a router. Although we do certain kind of hardware level optimization in a commercial router or a typical router that are designated like a router, we'll talk that later on. But any machine works like a router. And you can have this route command to check the routing entries in your machine. Okay, you can do route -n. So here is the routing entries in my machine. You can see that there are 3 different entries. Well, so the network IP is 0.0.0.0, gateway is 192.168.1.1, network mask is 0.0.0.0. Some other flags that I have not used earlier, the flags, metric, reference. This metric is something like a routing metric. It defines about the routing cost, that how much cost. So this Linux has its own way of calculating this routing metric. We'll discuss that later on. It basically determines that what is the cost of reaching to this gateway via the interface. This last column is the interface. Yeah, the last column is the interface. Through this interface, if you want to reach to this gateway 192.168.1.1, then what is the routing cost? So it is 600. So you will see that while calculating the routing table entries, we always try to take the shortest path, and that I will discuss in the next class. But these are the 3 other parameters that we use: flag, metric, reference, and use. The other things I have shown in my slides. So here you see that I have a default entry because currently my machine is only connected to a Wi-Fi network. I do not have a kind of RJ45 cable or any other interface currently activated. So that's why I have the default entry where the destination IP is 0.0.0.0, net mask is 0.0.0.0, the default entry. Then the gateway is 192.168.1.1. That means whatever packet you want to forward, and the interface is WLP3S0. That is the interface corresponds to my Wi-Fi network. Okay, so that means whatever packet you want to send outside, you send it through this particular interface. And there are 2 specific entries. These 2 specific entries are actually corresponds to 2 different subnets which are running in my dongle. That means the Wi-Fi access point internally. I have just created you to demonstrate it to you. So there, the destination is 169.254.0.0. Net mask is 255.255.0.0. Here the gateway is 0.0.0.0 because I am not mentioning any gateway because in that case it will just take the gateway which is currently activated. Okay, and currently I have a single interface which is the WLAN interface, so it will take that as the gateway, and it has taken the interface as WLP3S. Well, so that way you can have the routing entries, and if you connect your machine both with the RJ45 cable as well as with Wi-Fi, you can see much more number of entries, the routing entries in your machine. Well, okay, so that's all for today. And as I have mentioned, in the next Monday class, we are going to start with that how we are going to create such kind of routing table dynamically within a router. So that's all. Thank you all for attending today. If you have any further question, feel free to post it in the Teams chat. We are going to meet on next Monday at 11. Thank you. Take care. Bye bye.